to a plus 2b. How would I do this then? How would I know what to do? Okay, so I'm going to give you, remember I told you, there are sometimes things that you can do by convention that will always give you the right answer. Or you can try to figure it out every time, and under test conditions, 90% of the time you get the wrong answer. So here's a way to always get the right answer. If you want to know the relationship, you take the amount of A used up, CA0 XA, and the amount of B used up, CB0 XB. And what you do is you divide by alpha 2 minus alpha 1 and beta 2 minus beta 1. That is, you divide this one by 1 minus 2, and you divide this one by 2 minus 1. So if you do that, you'll always get the right answer with the right sign. So in this case, if I have 2a plus b goes to a plus 2b. So in effect, I'm losing an a and gaining a b. So this says that CA0XA over minus 1 is equal to CB0XB over plus 1. It says I lose every A I lose, I gain a B, which is exactly right here. What people do on tests, I'm telling you, no matter how many times I tell you, tell the students, on tests, instead of dividing, people multiply. And they always get the coefficient in the wrong place. That's because they don't use the formula. Do it this way, you'll never make a mistake. Well, here it's easy because there's zeros on the right, so I divide both sides by minus 1. So they're equal. And that's how I get that these two are equal. Okay, so now I have that CA, which is CA0, 1 minus XA, and CB is CB0, 1 minus XB, which is equal to CB0 minus CB0 XB. This is a definition, and then I just multiply it out. And I know that CB0 XB is the same as CA0 XA. So this is CB0 minus CA0 XA. And I can factor out a CA0. And I can call this ratio from the reference state M. So I have this is CA0 M minus XM. And then what am I left with? I'm left with this is equal to minus K CA0 1 minus XA times CB, where CB is another CA0 M minus XA. Is that clear? Lightning algebra. And again, dCA is CA0 times minus dXA. So I'm ready to plug into the formula. So I have the integral. Here's the formula. Okay, what do I get for dCA? What was I up to?
Minus CA's not dXA.
dXA. That's dCA. And now, for F2 of C, what do I plug in? What is F2 of C? CA naught squared. You have to speak a little louder so someone can hear you.
1 minus XA and M minus XA.
Anything else? You take care of this, and minus. Okay, and this, so the minuses cancel, and one of the CA0s cancels, but not both. And let's just keep the other side of the equation. The other side of the equation is KT. So now I have to do this integral, and this goes from XA of 0 to XA of B. How do I do these integrals? What's the technique for you doing these intervals?
Partial fraction.
Partial fraction. So I'm gonna write so far over on the blackboard to make sure that the people on that side can see. Okay, so I want to look at 1 over 1 minus xa, m minus xa. And write that as a coefficient a over 1 minus xa plus b over m minus xa. Where I want a and b to hold for all xa, not just for one xa, for all xa. So I'm going to multiply through by the denominator, and then I'm going to get a polynomial equation. And I want the polynomial on the left to be equal to the polynomial on the right, meaning all the coefficients of all the powers of x have to be the same. So when I multiply by this, the polynomial should be 1. And here I have a times m minus xa plus b times 1 minus xa. So I multiply through by this. And this is a polynomial. It's a linear polynomial on the right. And I have a constant on the left. The coefficients of the like powers of x have to be the same. So I get 1 is equal to, what's the constant coefficient on this side? Who was that?
Constant coefficient is a1 plus 1.
Plus 2. And how about the coefficient of x? Power of x? What's on the left? 0. And on the right? What's the coefficient of xa on the right? Remember, if I'm going around the room, it's trivial. Higher mathematics. What's the coefficient of xa on the right?
It's minus a minus b.
Minus a minus b. I can't believe anyone has trouble with that. Okay, so this tells me b is equal to minus a. And if b is equal to minus a, then this is a times m minus 1. Which tells me that a is equal to 1 over m minus 1. And b is equal to minus 1 over m minus 1. So now I go through and I have kt is equal to dxa times integral xa of 0, xa of t. And here I have kt, 1 over m minus 1, 1 over 1 minus xa, minus 1 over m minus xa. Where I plug in for this, 1 over m minus 1, and for this, minus 1 over m minus 1. I factored out the m minus 1, and here's that minus sign. So this is equal to. Okay, so now I'm going to multiply through by m minus 1. So I don't have to write that 100 times. And that's equal to, what's the integral of dx over 1 minus x? What was I up to? Log of 1 minus xa minus. So I'm going to evaluate xa of 0 over 1 minus xa. So I flip the limits with the minus. And now I have minus, what's the,
Log 1 over log m minus xa.
with the minus sign.
Yes.
So then I use the minus sign to kill this minus sign. And I've got the log of n minus xa of t over n minus xa of 0. What happens when I add logs? What's the sum of logs? Times what? A full sentence. The log of, the sum of the logs of two numbers is equal to the log of the product of the two numbers. So this is the log of 1 minus xa of 0 over 1 minus xa of t, m minus xa of t, m minus xa of 0. And that's equal to n minus 1 at. So here's a situation, we're using the xa's as we could have set these equal to each other and written CB in terms of CA, and that would have been equally fine. The algebra would have been slightly longer. Okay, you can, now just for fun, we can see what that's equivalent to. Again, I need my pink chalk. If I multiply top and bottom by CA0, CA0, and another CA0, another CA0, what would I get? Well, CA0, 1 minus XA is CA. So I have the log of CA of T. CA is 0. And CA0 m minus XA, CA0 m minus XA is just CB. So this is CB of T, CB of 0. And that's equal to CB0 over CA0 minus 1. So here's the same answer written in terms of CAs and CBs. Any questions? Now, of course, there's a special case here that I've neglected. And what's that special case? What's the special case I've neglected here? When does what I just erased break down? I had 1 over 1 minus XA, 1 over m minus XA. So that's equal 1 over m minus 1, 1 over 1 minus XA minus 1 over m minus XA. When does this not work?
You mean the denominator is equal to 0?
For example,
So when m is equal to
when m is equal to 1. This clearly only holds when m is different from 1. So this is for m not equal to 1. So I should look at the special case where m equals 1. When m equals 1, well then I have a special case of this. Well, sorry, let's not even do that. When m is equal to 1. What happens when m is equal to 1? When m is equal to 1, that's something we actually spoke about last week. When m is equal to 1, that means the reference state, the ratio of CB0 to CA0, is the same as the ratio of the stoichiometric coefficients. What do we call that? What do we call that method? Who's that? Did you look at your notes? You know that you're supposed to look at your notes before you come to class? You want the whole class to love you because you're going to take a quiz? You're going to look at your notes every class, before every class from now on? I can't hear you. No. People are not looking at your notes. We're going to have quizzes. I'll make a quiz every class. It's okay.
Love math action.
No.
Method of stoichiometric ratios?
Stoichiometric ratios. Okay. This is very poor. You understand? When I ask a question that just is a spitback of what we did in the previous class, if I have to ask 5 people, it means you're not taking me seriously when I say I'm going to give you a quiz. So I don't know how much clearer I can be. I'm going to be very explicit. The next time this happens, there will be a quiz. If it happens twice in a row, 2 classes in a row, we'll have a quiz every class. Do you want to have a quiz every class? You usually do that in 2nd grade to teach students a little discipline because 2nd graders don't have any discipline. College students are grown-ups. So you're supposed to have discipline. I don't want to treat you like 2nd graders. So if you don't come to class prepared, you're coming in with a sign saying, please treat me like a 2nd grader. Please treat me like a 2nd grader. And if you say, please, I'll treat you like a 2nd grader. Don't make me treat you like a 2nd grader. I don't want to do it. But I'll do it if you force me. Understand? That means you can look at your notes before you come to class. fair warning. Okay, so what happens there? In that case, if m is equal to 1, let's see what happens there. Then I have kt, this expression, is equal to the integral from xa of 0 to xa of t of dxa over 1 minus xa squared. What's the integral of dxa over 1 minus xa squared? Sean? No. What's that? You want me to write it so you see it? All right. Sean? This is barely high school stuff, barely. Who passed calculus? I've used the minus sign to flip the limits. How many people, including graduate students, don't know how to integrate 1 over x squared? Apparently a lot. That's inexcusable. And again, with our pink chalk, we can multiply both sides by CA 0. That is, we can multiply top and bottom, if we like, or let's divide both sides by CA 0. And that tells me that 1 over, I need some more space.
You're multiplying and dividing actually. With the pink.
I'm sorry?
You're multiplying or
I've
dividing?
divided both sides by CA 0. That gives me KT over CA 0 is equal to 1 over CA of 0 minus 1 over CA of t. And I can, so I have 1 over CA of t is 1 over CA of 0 minus KT over CA 0. I can invert this and I have CA of t is equal to 1 over CA of 0 minus KT over CA of 0. And I can divide by CA of 0. And that gives me where I have CA of t over CA of 0 is equal to 1 over 1 minus KT CA of 0 over CA of 0. Did I lose